Hari Om. I am Ajay Kumar K, Assistant Professor of Mathematics at Chinmaya Vishwavidyapeeth, and I welcome you all to the webinar, A Conversation with Professor S. Bhargava. We have gathered online to celebrate National Mathematics Day, the birth anniversary of Srinivasa Ramanujan. We at Chinmaya Vishwavidyapeeth believe in celebrating and promoting the scientific heritage of India, and this day presents yet another opportunity for us to do that. Ramanujan's contribution to mathematics is renowned worldwide, and his works are relevant and significant even now, 100 years after he passed away. In order for us, the mathematics enthusiasts, to understand the unparalleled legacy of Srinivasa Ramanujan, CVV marks this occasion through interviewing a well-known mathematician, an expert in several areas of mathematics ranging from pure to applied mathematics, including Ramanujan's mathematics, Professor Srinivasamurthy Bhargava. Allow me to introduce Professor S. Bhargava. Professor S. Bhargava is a former professor and head of the postgraduate department of mathematics, University of Mysore. He holds BSc Honours and MSc Maths degrees from Central College, Bangalore, BE degree from Indian Institute of Science, Bangalore, MS and PhD in mathematics from Carnegie Mellon, Pittsburgh, USA. He is also a former US government senior Fulbright fellow at University of Illinois, USA. Besides IITs, IISc, and various universities of India, he has also visited several teaching and research institutions of USA, Italy, and Japan, including universities of Wisconsin at Madison, of Pittsburgh at Pittsburgh, Purdue at Lafayette, International Center for Theoretical Physics at Trieste, and universities of Kyoto, of Nagoya, and of Kinki in Japan. He has published several individual and collaborative research papers in optimization and control theory, atmospheric noise filters, electrical networks, continuum mechanics, univalent functions, number theory, Ramanujan's classical and alternative theories of theta and elliptic functions, Q series, Q continued fractions, and sums of powers representation of a number. His papers, ranging in length from short to medium to voluminous, have appeared in several Indian as well as foreign journals of high repute. To name a few, Journal of Optimization Theory and Applications, Networks, Siam Journal of Applied Mathematics, Transactions of the American Mathematical Society, Proceedings of the American Mathematical Society, Memoirs of the American Mathematical Society, Integral Transforms and Special Functions, International Journal for Mathematics Education in Science and Technology, Journal of Mathematical Analysis and Applications, Fibonacci Quarterly, and Bulletin of the Australian Mathematical Society, among others. He is a joint winner, along with B.C. Burnt, of Lester R. Ford Award of the Mathematics Association of America. He is a fellow of National Academy of Science, India, and former president of the Indian Mathematical Society and former president of the Society for Special Functions. Professor, it is indeed our privilege to have you with us on this occasion. I welcome you to this virtual event, and on behalf of Chinmaya Vishwavidyapeeth, I wholeheartedly thank you for accepting our invitation and joining us despite your busy schedule. Welcome you, Professor.
Thank you very much.
With your permission, Professor, shall we begin the interview?
Yeah, please.
Okay. Srinivasa Ramanujan is considered a mathematical genius. He is arguably the most well-known Indian mathematician ever. Professor, you have visited several countries and have interacted with eminent mathematicians around the globe. Can you tell us what is the stature of this legend, Ramanujan, in the mathematics community worldwide today?
Very, very high. So, so wherever I've been, whenever I gave lectures, or the lectures were heard with great intent. The audience were large, and especially they appreciated Ramanujan's elementary methods. Uh, so my lectures, I made it a point to give my proofs involving elementary techniques rather than the modern techniques of say complex function theory or modular function theory and so on and so forth. And you know, his reputation is very high because there are his followers all over the world. Maybe New Zealand, Australia, our Asian countries, and United States of America, countries of South America, Canada, and so on and so forth. Not to speak of ourselves. So the followers. And there have been followers right from one of his very first followers were Hardy himself, G.H. Hardy's mentor, professor of mathematics at Cambridge University. And then there have been hundreds of his followers all over the world, and hundreds of papers have been published on Ramanujan's mathematics all across the world. Dozens of books have been written on his mathematics. Several awards have been instituted. For instance, the Italian government, in collaboration with United Nations Atomic Energy Agency, have instituted a $10,000 award at the International Center for Theoretical Physics. Our Department of Science and Technology has instituted, and our comparatively new university, Shastra, has instituted 10,000 US dollars, and medals have been awarded to outstanding mathematicians in the name of Ramanujan. Biographies have been written, and the most famous one being due to Robert Canning. And then one of the earliest biographies, its unique biography, containing both the life history of Ramanujan as well as some of his mathematics, was by P.K. Srinivasa, and there are many other biographies written. And then have been held. For instance, uh, his 100th year of birth was celebrated with internationally to update the knowledge of mathematicians and physicists about Ramanujan's work. And in 2012, the then Prime Minister, Professor Dr. Manmohan Singh, is himself an economist and who knows the value of mathematics, especially in his own field, economics. He declared December 22nd as National Year of 2012 as National Year of
Year of
Mathematics.
mathematics,
And every year we celebrate it as the National Mathematics
mathematics
Day.
day. Yes, yes.
And then presently, of course, in those years, the conferences on Ramanujan were held throughout the world. Of course, the 1987 conference is one of the main conferences that were held in India, that was in Madras. It was unfortunately sort of truncated due to unfortunate death of then Chief Minister of Tamil Nadu, India. And this year also, in spite of the uh, pandemic, we have been having throughout the world conferences on Ramanujan. Ramanujan. And Robert Canigal's book, which I mentioned earlier, have been translated into a number of world languages. It happens to be one of the most authentic ones. And so this is how. This all speaks of high reputation that Ramanujan has up to date, and of course his works have uh, been focused more recently than ever. So his mathematics is growing more and more as the years pass. More and more international mathematicians, these youngsters, elders alike, have been working on Ramanujan. So that's the kind of reputation he has now.
Yes, Professor. So that sort of gives a feeling how special Ramanujan is. Can you tell us what are the attributes of Ramanujan that make him so special?
Of course, the single most great attribute is that Raman is genius. In fact, that single attribute covers a lot of other attributes like profundity and the extent of his work, meaning depth, inevitability, originality, and more significantly, simplicity and elementary nature of his methods, and then beauty and elegance of his formulas and examples. For example, Hardy, Ramanujan's mentor, once said, "There is always more in one of Ramanujan's formula than meets the eye." As anyone who sets to work to verify those which look the easiest will soon discover in some interest lies very deep, in others comparatively near the surface, but there is not one which is not curious and entertaining. Hardy also knew that Ramanujan could remember the idiosyncrasies of numbers in an almost uncanny way. I'm just quoting him. And that every positive integer were one of his personal friends. So that shows the, the length, depth, and beauty, curiosity, and so on and so forth. Ramanujan. That's the kind of attributes they can give.
Right, sir. Sir, these are things which are said by mathematicians because they understand the sort of work that Ramanujan has does. But for a layman, what happens, for example, on social media these days, I myself have seen several messages where you see trivial facts, say, for example, some pattern which is observed in the mathematics table of 9, and they say this was discovered by Ramanujan, and so Ramanujan is great. So, what happens? People are attributing trivial facts to Ramanujan and calling him genius because they technically do not understand what sort of works Ramanujan has made. Can you please tell us how a layman can understand the spirit and greatness of the works of Ramanujan, not really being technically sound about mathematics?
Yes. Oh, not only layman, but all of us, the so-called experts and those who want to get initiated to even Ramanujan's mathematics. I think we should go through some authentic Ramanujan biographies contained in the publications of people like G. Andrews, B.C. Burnt, G.H. Hardy, Robert Canigal, I mentioned earlier, Ken Ono, P.K. Srinivasan, to mention a few. Among these biographies, as I said, the most popular and researched is Robert Canigal. Interestingly, he was a mechanical engineer turned journalist and a professor of science writing at Massachusetts Institute of Technology. Canigal's masterpiece titled The Man Who Knew Infinity, that's the name of the book, the biography of Ramanujan. And he wrote it slightly after Ramanujan's birth centenary. And it now is translated into almost number of world languages, including Indian languages, as I said before. And as I said before, P.K. Srinivasan was born But 4 years after Ramanujan's death, and who lived up to say 80 years, is actually a precursor among Ramanujan's biographers. He was an unconventional but yet popular high school teacher from Madras, now Chennai. He started his teaching career in village schools in 1948, and he started with the mission to spread the inspiration of Srinivasa Ramanujan's singular life of extraordinary creativity in mathematics in order to discover potential Ramanujans. I quote from one of his own articles. Untiringly, he made efforts all his life towards achieving his mission in multiple ways. One of the offshoots of his efforts were two-volume Ramanujan Memorial Number, published during the 75th year of Ramanujan's birth. I especially mention this. This is one of its kind. Uh, and very authentic. And of course, the two books, one of the volumes contains Ramanujan's life, letters, authentic letters, and so on and so forth. And the other one contains a number of articles by all kinds of teachers of mathematics in India and abroad. Uh, uh, and the articles pertain to Ramanujan's, some of Ramanujan's elementary works, I should say. Elementary in the sense that they can be understood, the proofs can be understood by sort of layman, you can say, some middle school, high school level knowledge with high school, middle school level knowledge. And so that's the beauty of those two volumes. And he worked hard all his life. So I especially mentioned it. A layman may also be impressed that not all, not even experts, can understand everything. The best way for a layman is to pick what one can appreciate and understand and go further. I would recommend Srinivasan's memorial numbers to start with the one I mentioned just now. I may also bring to the attention of the audience the book Ramanujan at Elementary Levels, Glimpses by V.R. Thiruvenkatachar and K. Venkatachalanga, who are both of them are no more with us. Their birth centenaries were celebrated a few years ago. And that book of Venkatachalanga and Thiruvenkatachar have been edited by Bruce Burnt and his associates, his students. You may have heard of Atul Dikshit is one of the co-editors of that book.
IIT Gandhinagar, yes, sir.
Yeah, Gandhinagar. And that book is entitled Ramanujan for Low Bros. I'm sorry. The book, the title of the book I already mentioned. See, I also recommend, for instance, a bit more involved than Srinivasan's. The paper entitled Ramanujan for Low Bros. And incidentally, I also happen to be one of the co-authors with Bruce Byrne of that, and we together got an award for that, the one you mentioned earlier, of the Mathematical Association of America. So that's one of the mathematical articles. A layman, I would say, by layman, I understand at least a high school level. Even high school level, and by going to those works, they can understand that while what Hardy already said, I quoted Hardy said that things may look beautiful on the surface, but still they may be deep when you go through them in some detail. So that's the kind of articles mentioned in Ramanujan for Locals, just introduced. So that's what layman and experts and those who want to start looking at Ramanujan's works, I think I recommend that they go through those works.
Yes. Thank you, sir. Thank you for recommending the list of these biographies, and I myself is now interested in picking up a couple of them and start working on this. Sir, you were mentioning about Hardy, and we know those who know a little of Ramanujan, that the biggest turning point of his life was his letter to Professor G.H. Hardy at Cambridge.
Yeah.
So Hardy's role in Ramanujan's life has been significant. Their collaboration, you already called Hardy as a first follower of Ramanujan, and their collaboration is believed to be one of the best in the history of mathematics. Also, this is an example of great accomplishments that can be achieved when the East meets the West, which is one of the goals of our university, Chinmaya Vishwavidyapeeth. Sir, can you tell us what made Hardy invest in Ramanujan's ideas and what was the kind of influence Hardy had on Ramanujan after that?
Well, actually, it's very pretty simple, like is any good human being in a great teacher would do. So Hardy could recognize the potential in Ramanujan at once when he went through in detail Ramanujan's letters communicating a large sample of his mathematical findings, done in isolation as a two-time college dropout. Hardy was impressed by the background also. Hardy decided to help Ramanujan in his mathematical pursuits by getting him to the atmosphere that Cambridge provided. So that was the first intention of Hardy. He didn't know how far he could collaborate, etc., etc. So that his first intention first reaction was that. You called it investment, but I would say that he just wanted to help Ramanujan. Hardy decided to help Ramanujan in his mathematical pursuits by getting him to the atmosphere that Cambridge provided. He probably had no other intentions, even though Ramanujan's presence in Cambridge turned out to be of great advantage to both. That resulted in some of the historical collaborative work, as you already mentioned, besides Ramanujan's independent achievements. One must say here that some of Ramanujan's earlier works done in isolation in India did serve, now when you talk of investment, did serve as important initial steps to their collaborative work, like though the work in partitions, the historical work they did in partitions. And
Partition.
the crux of the matter was it was one of the a very approximate formula Ramanujan had for the number of partitions
Partitions.
number. That was the starting point. And then, of course, Ramanujan did have an idea of complex analysis, like Cauchy's theorem and so on, which probably Ramanujan learned, or I don't know whether he learned. But he had great. His intuition was very deep, rich. So he probably absorbed later on what Cauchy's theorem was, without having to go through the proofs. So probably that, and then the circle theorem they did in estimating the the behavior of functions near this unit circle. So that's one of the potential techniques they developed, and it's all because of Ramanujan's insufficient or first approximation works that he did, or intuitive works, or whatever little tools he had with. So he did in India. So that's one of the uh, great collaborative achievements, and it goes to the credit of Ramanujan also greatly, because the work they did on partitions is supposed to be one of the landmarks in history of mathematics. So that's, you may call that sort of turned out to be an investment without Hardy meaning
Right.
that.
Right,
It
sir.
was not Hardy's intention to do any investment. He just helped Ramanujan, if I may say so, and it turned out to be a rewarding
Reward.
thought of Hardy. And as any great teacher, human teacher would do to even strangers, those who are interested in mathematics or in any field, whatever. So that, I
Yes.
think that's the answer to your question.
Yes, Professor. So, uh, Professor, you have worked on Ramanujan's notebooks. We know Ramanujan recorded his works in India in his notebooks, and you have contributed immensely to the area of special functions, Q series, continued fractions, and other classical areas related to Ramanujan's works, and including a chapter in Ramanujan's second notebook, compiled and edited by Professor B.C. Burnt. Professor, when did you start working, or when did you start studying the works of Ramanujan? What or who inspired you to work on this topic?
Yeah, it may be a little disappointing to you, but anyway, let me say that. In fact, I mean, one part is could be disappointing, but not all. I say some of them may be of some information. In fact, there are more chapters than one in Burnt's volumes on Ramanujan's second notebook, based on our collaboration. You probably are mentioning one with Adiga and so on. So
Oh,
that
oh,
was the,
I'm sorry. I'm sorry, sir. I was referring to chapter 16 only, but
yeah,
I'm sorry.
that was the
Yeah.
one of the first we wrote, and then
Okay.
Bruce Burnt and I have collaborated on more chapters than one, like one inversion of series and integrals, which gets into mechanics and heat transfer and all over, and I don't know. There may be, yeah, the one more, the more involved, more intricate and longer chapters is on alternative theories that came in Transactions of the American Mathematical Society. That has been incorporated in his book, one of his books on second notebook, Ramanujan's second notebook, one of Bruce Burns' books. And moreover, many of the contributions made by me individually and in collaboration with my students and with my grant students. I don't know if
Yeah.
I've made any collaboration with great grant students. I stopped thinking. Anyway, many of these works find their place in Burns volumes as well as those of Andrews and Burnt and Ramanujan's last notebook. So it's all there. A lot of work has been incorporated. So this, so it's, and also you may be disappointed that I started working on Ramanujan's works pretty late in my life, at the age of 40, not as a
Oh,
student or a research scholar, not a doctoral student, nothing. I took it off. I was already a full professor, when I started on Ramanujan. I just wanted to diversify from one, and then I stuck to Ramanujan. It was absorbing. The rest of the active period, I've been working on his mathematics. So I wanted earlier, as you already mentioned from my biodata, earlier I was into and had published in the areas of complex analysis, optimization, and control theory, and so on and so forth. Atmospheric noise filters and
electric
gas
networks.
continuum mechanics and the electrical network. Because of my background, I was sort of uh, and then of course why I got into Ramanujan's work uh, was on reading Professor K. Venkatachalanga's lecture notes and Professor T.S. Nanjundeya's
Okay.
papers. Uh, I got interested. So on reading them, I got interested in carrying out research on Ramanujan's work. And Professor Venkatacharanga was one of the first, probably the first, to uh, to to integrate Ramanujan's works into classroom lectures. So, with lots of examples and theorems and so on and so forth, he taught Ramanujan's mathematics, especially Ramanujan's last notebook. He
Lost
taught
note.
topics from Ramanujan's last notebook to his MSc students. So I was lucky to get hold of his classroom notes. One of his illustrious students, V. Ramamani, who lives in Mysore, in Bangalore now. One of the first to work for DRDO. Thiruvenkatachara I mentioned was also one of the, I can say, founder scientists of DST. I'm sorry, DRDO. So the Ramamani spared me her notes, and so I was delighted to get introduced to Venkatachalam was teaching, classroom teaching, and that's how I got started at the age of 40 after I became a professor, full professor. Probably I was also head of the department at that time. So it's so pretty late, but better late than never. See. So
Right.
I
Right.
also owe a lot to my illustrious colleagues and doctoral students who joined me in my efforts in the department. So that's how it all happened. I think.
Okay. Okay, Professor. I'm sorry about my ignorance on your other works in collaboration with Bernd reflecting in his notebooks.
And,
I'm sorry.
and I must say, my students and grand students work. So they did a lot of. They have done. Some are collaborative now. They are doing their own things with their students and grand students and great grand students. Maybe I don't know.
Right.
So it's getting richer and richer day by day.
Right. So I, being a student of University of Mysore, the math PG department of mathematics, I have seen the influence that you have made, and your students and grand students now they are continuing with the research culture, especially the elementary approach and the approach to Ramanujan notebooks, the way Ramanujan approached it, than alternative things which you
Yeah,
actually had worked on.
in fact, Burns and Andrews and all those great experts, they keep telling that even though thousands of papers have come out, books have come out, and proofs have been given of almost all of Ramanujan's conjectures, if you may call, or his theorems, his statements, an equal amount of work remains, maybe for another century, in finding proofs that Ramanujan probably had, the elementary proofs. The elementary proofs are still wanted in most of the cases. So that's the
That's the treasure the man
yeah,
has
yeah,
left
yeah,
behind
yeah.
with us.
So one can keep digging
Right.
for years and years, decades. Maybe. So that's still a challenge because Ramanujan's armory was very limited. It's very small. So he managed to do a lot just with a few armory, small armory. So that's the challenge. And modern mathematicians have all kinds of sledgehammer methods to use, and that's how they have done it.
Yes.
Most of his things are so the elementary, getting elementary proofs, and also Ramanujan sort of had a unified vision, perhaps, of everything he did, whatever the compartmentalization we can really afford to do, but probably had a unified vision of everything he did. So that is still another challenge to unify everything as much as possible of what he did.
True, true, sir. As somebody who has some background in education, in mathematics education specifically, one of the goals is to decompartmentalize mathematics right from school level. Probably this aspect of Ramanujan, I think, is something which people should consider seriously and try to
Yeah,
bring in such thought process.
yeah.
Sir, I have a couple of questions out of my personal experience with students and my friends. So the first
Mhm.
one is, as I told, when I interact with school students, I have hardly come across young school students who wish to become a mathematician. I even doubt if many of them understand what it means to be a mathematician. So, Professor, can you take us through your journey from a mathematics enthusiast to a mathematician and help us understand how a mathematician basically works?
Yeah, my journey, of course, has been very, very long. But I don't know how much I strayed and how much I focused, I do not know. But everything has helped me. First of all, how a mathematician works is highly individualistic, I think, like in any other field
Okay.
or fields. To put it simply, going by the ways of some of my own numerous illustrious teachers at home and abroad, and that of Ramanujan himself as a student. One should be a student all the time. Now, all my teachers, they ripe old age. So some of them died. They kept on working till the age of 89, 90. Till they died. They were all students. They remained students of mathematics. So that's one of the way a mathematician, anybody can become a mathematician or anything else. What they are interested. So so they were full time and all time students. So that's and of course hard working student at that. So
Right.
so that's the probably in a nutshell how a mathematician, how one can become a mathematician or anything else. So it's just hard work and focus and in things and being a student all the time. That's the thing. Of course, each one has his limitations, or each one has his or her limitations. So that's one has to work with limitations. All my teachers were great problem solvers. I'm talking mathematics teachers. And of course, in any other fields, there will be equivalent situations. Everything is a problem for especially mathematicians. As mathematicians, we are familiar with what our problems are. So they were all great problem solvers, my teachers. So that's one of the qualities a person should have to become a mathematician. Uh, Problem solving, especially at young age. See, if without being problem solvers at young age, we can't hope to become problem solvers later.
Later.
The chances are less. I'm not saying that it's impossible, but the chances will be less. Uh, and of course, my teachers were students, as I said, hardworking students all the time. Now, irrespective of their previous accomplishments or other qualities or reputations they had, one has to keep on working. Actually, my doctoral advisor or doctoral supervisor, no, he used to be working all the time in his even in his ripe old age in his office, and his desk was just his desk used to be full of his papers. So then I used to ask him, "Oh, you've done so much." Then I said, "Bhargava, just keep on working." That's what he said. Just keep on working. They'll pile up. So that's all he
Right.
said. Nothing else. Nothing else. And his wife used to come late in the evening and drive and put his bicycle in the dicky and drive him back home at whichever time he wanted to go back, middle of the night and so on. So he was at the right. His name is R.J. Duffin, and I'll come back to him later. So this is one of the things. And in my personal case, uh, travel turned out to be a best means of education for me, apart from my teachers and friends and classmates. Because you can learn a lot as your experience goes, perhaps too. You can learn a lot from your classmates, your
True.
colleagues,
Peer group. Right.
especially classmates. If you have very competitive classmates, then
Yes.
your focus will be all the more sharp, and you'll have to work harder if you are competitive yourself. Of course, I mean you means in general anybody,
Yes.
and
Yes.
so that's also a proverb. Travel is the best means of education. So you may proverbs generally are also half truths, but in my case, it turned out to be the most rewarding part. It so happened. I just want to give me because you asked me about my journey.
Yes,
As
sir.
my journey. uh, I created a record, sort of a record, thanks to my father who had a transferable job. He used to get transferred every year, and sometimes two places in a year. So as a result, by the time I passed out my matriculation, that is SSLC, secondary school leaving certificate. It used to be 11th standard exam for us in those days. It is 10th now. So we used to do 11, to go through 11 classes, 11 years.
11 years. Right.
Yes. So I went to, believe it or not, I went to 12 schools in 12
Oh,
different places, villages, small towns, big towns, cities, including Bangalore. I, I got my SLC in Bangalore. Uh, so and lo and behold, it turned out to be my advantage in all places, including small villages, remote villages, which still remain to be, same villages. except there are street lights and asphalted roads. Otherwise, they remain the same. Some of them. They were all great teachers, especially mathematics teachers. They were very devoted and thorough, and they helped students. They loved their students. That's one of the best things that can happen to anybody. You have a great. I should particularly talk of my eighth standard teacher to begin with. In those days, we followed the British system, pre-independence days,
Yes,
and the
sir.
British system in all financial dealings with it, whether it's length, time, or work or energy or whatever you have, monetary system. Everything was British system, and it meant that whenever we had to calculate interest, that was arithmetic. It used to be called arithmetic. He used to teach. Our headmaster used to teach arithmetic and English, and he excelled in his teaching, and he was also so helpful and an exemplary teacher, and such a complicated arithmetic. We had to learn a lot of conversion tables. We had rupees, anna, paise, and then tola, visa,
Right.
mana, and so on. So it's all in a remote joke falls, just that place, and he made things very complicated. Sort of, complicated things very simple. All that he did was, step by step, what do you call it, programming. No, so he divided everything into number of steps, simple steps, and he
Al-
taught us how to overcome a difficult problem like calculating compound interest time work and time distance problems and so on and so forth. So we were introduced to this sort of programming long ago. What is now you call programming in computers.
yes,
So
sir.
so we were boys, like eighth standard students, we were like 12, 11, 10, even 9-year-old boys and girls used to be in our classes. He made things very simple, very impressive, and made everything very interesting. And then I must probably you heard me talk about them. Uh, I must mention, because all the teachers, as I said, right from all these schools, and then my intermediate level teachers, I was in intermediate level teachers of those levels. I mean, at those levels, and then in my honors, MSc, and then in Indian Institute of Science or even abroad, they were all tremendous teachers. I was lucky. I mean, each one has a different way of doing his own thinking. So we get an opportunity when you are incident to number of teachers, you get so much more arms. See, to deal with. So so they share a bag of tricks of their own. So you become a
Yes.
sort of resultant of bits of their tricks. So you have your own armory in that case. So that's an advantage. And besides all this, being experts in mathematics, I want to mention two teachers of great human qualities. That's an essential thing to be a teacher. First of all, a teacher should be a human being, and then
Right, sir.
everything else comes. And this one of them, on my honors in the honors level, both in the honors level. One was a physics teacher, an elderly teacher, and another was comparatively a youngster in his mid 30s, and the younger teacher happened to receive a letter of promotion that
Okay.
he has been promoted to assistant professor's post. And the background of this young man was strangely, he was a mason's son, see,
Oh.
poor
Hmm.
son, and he taught us all kinds of geometries in honors and MSc, different geometry, and then pure geometry as they used to call, projective geometries, analytical geometry,
Spherical geometry.
dimensions, and covariants, invariants. He taught us everything, and he was a great teacher. He was a great problem solver already at that young age, and his background was he was a bricklayer's son, a mason's son, and somehow he also used to tell us how he used to go to a second-hand shop, a bookshop, and there the owner used to spare him the mathematics books, and he used to do the problems then and there and return the book, and because he couldn't afford to buy a book. So that's how he studied. And he happened to, I mean, deservingly, for some reason or the other, he got a promotion letter. You believe that he returned the letter to the government? In those days, it was the ministers who directly promoted the teachers, university teachers.
Okay.
He returned saying that many of my teachers are still lecturers, so I do not want this promotion. So that's the kind of, and he remained that for many, many years. And so that's the kind of a human side a teacher should have. And the other case, the case of one of the elderly teachers. He was a teacher of physics. We also had to study physics, even though our major was mathematics.
Mathematics.
To call honors level, and he too received a letter of promotion from the government. One of the ministers saying that he has been promoted to assistant professor. So he was a lecturer. And then he returned saying that, please, sorry, I cannot accept this position. You have asked me to be on probation for 2 years, and I am retiring in 2 months. He said that. He got his first promotion. And that. Of course, he was a famous teacher and he had produced many great students. And some of them were IAS officers working right in the ministries as chief secretary or somebody. And they prevailed on the government to alter the wordings of the order, and the condition of probation was removed. And then probably, I do not know whether it's still accepted or whether they are already retired by that time. So he's another, and he has produced many great teachers. I don't want to mention their names because his sons, especially, were also, great academicians. They became great academicians. One taught in TFR, Bombay, and another as a great aerospace research, aerospace who learned from Caltech, fluid mechanics, and so on and so forth. So he was a great teacher himself, and so that's the kind of story. So a teacher should have a human side also, and that's what. So it is. I mean, this is all the making of an academician, especially mathematicians. So that has been my journey. See? I don't know whether it was interesting or irrelevant.
No, sir, definitely it is. It is in fact inspiring, and I'm sure young minds who are watching this would be inspired and motivated to take up mathematics and maybe become a mathematics teacher or a mathematician, a researcher, and whatever level it is. But
Yeah,
I'm sure it's inspiring, and thank you, sir. Thank you for recollecting this journey. And one more
you
question,
asked,
sir.
because you asked about my journey. I had to tell you all this story.
Yes, sir. I had, of course, once listened to you on some aspects of your travel and other aspects. So I just wanted you to recollect so that we as youngsters get inspired. So that was the
Yes.
intention, sir.
Nice opportunity for me too.
Right. So another question, sir. As
To become nostalgic, sort of.
nostalgic. Yes, sir. So another question that I had out of my personal experience is, as a researcher, as a young researcher, I work in pure mathematics, and personally I come across people who ask me why one should do pure mathematics. How is it going to change the world, or how is it going to make any difference? But we know Ramanujan's works in pure mathematics over 100 years ago find applications today in areas which were not even existing during his time. For example, say signal processing, black hole physics. These are two major areas which find applications of Ramanujan's works in pure mathematics. So, Professor, this kinds of brings in a debate on pure mathematics versus applied mathematics. You, a mathematician who has worked in both pure and applied mathematics, what is your take on this?
Actually, when I worked, when I was a student, I didn't know what I was doing, whether I was doing pure mathematics or applied mathematics. And even now, if you ask a mother, no,
Yes, sir.
suppose she has a dozen children, you ask, whether which son she likes or which daughter she likes, whether she likes sons over daughters and daughters over sons, she will have no answer. Uh,
Right, sir. True.
I think. And also, I have been like a wanderer, as you can see. So if you ask a wanderer why he wandered here, why he wandered there, probably he would have an answer. It's all, it's sort of accidental, maybe planned, or maybe planned for a short time, not planned for a longer duration. See, it may so happen. So, so frankly, I have no takes on this kind of debate. I mean, naturally, no. Uh, your question itself contains the message that such a debate could be futile. Going by the history of evolution of mathematics, you mentioned about Ramanujan's mathematics and its applicability now, and of those fields with the evolution, if you go through the evolution, the history of evolution of mathematics and those fields which connect with connection to mathematics, we realize that it may be very futile to discuss about what is pure, what is applied, what is pure, what looks pure today for some may
Right.
become applied to others or to the same sum of people. So the Ramanujan perhaps would have been surprised that some of the things he did in like theta functions and such. There's a lot of work on theta functions and classical theta functions and classical elliptic functions of Jacobi and Weiss, works of Jacobi, Weierstrass, Abel, and so on and so forth. Ramanujan did all that in his own language and notations, and it was very rewarding for him and others who follow him. And so, and he did a lot, but probably he was aware that these theta functions were ubiquitous, so to say. They come from nowhere. They may come from, for engineers, they may think that the theta functions came into being because of their engineering problems. Or yeah, the people who work in number theory may think of the same theta functions, that theta functions arose because of number theoretic problems. And the analysts may themselves think that they came on their own, and algebraists may think that they came from nowhere. No, but for algebraists themselves, and so on and so forth. So these are some of the happenings in mathematics. Different people work in different things, and they come up with the same object, like theta functions or elliptic functions. Elliptic functions, W periodic functions for some, and for
Right.
some, they're geometric functions with mapping properties. And for aerodynamics people working in aerodynamics and fluid mechanics, they may think that these conformal mapping, etc., are meant for them, to transform one kind of region to another kind of regions, convenient region, and study the flow, etc., etc., and so on. So these arise. So some of the functions, some of these concepts, say so, arise from in different areas, in different ages, and in the hands of different kinds of people. Maybe physicists, maybe engineers. I mean, scientists in general, all different kinds of scientists. So this is a sort of a time. It is all these, this. As far as I think, and many of the teachers whom I have been taught or with whom I have been associated right from the beginning, according to them, they have always thought of, I mean, at least as more and more you work, the more and more you realize that they're all a part of the same canvas. See, the moving canvas like clouds. They interact, they move from here to there. If you concentrate on a cloud for a moment, you see that it is fixed. But if you watch them over a length of time, they all move, they
More.
mix. So it depends on how long, our own limitations. You see, if I can, it's not a fault or something like that. It's all because of the time we have.
Right.
Each
Right.
one of us have a limited time to do our things. So during that limited time, we may concentrate on an area which seemed to be like number theory for me. In fact, Hardy was the one great analyst and number theorist who thought that number theory would never be applied in anything. So it's
Mm-hmm.
not of any use to others or of interest to others except number theorists themselves. But if you go through the, say, Fermat's works, Fermat was a magistrate
Yes,
and he
sir.
probably knew some mathematics. And
Hmm.
in those days, I'm talking of say 4 centuries or so ago, the magistrates, unlike of these times, they were not allowed to be sociable. So
Hmm.
whenever they were free from their work, they were confined to their homes. So Fermat, during that kind of isolation in his life, this professional life, he used to think of mathematics, and you all know that Fermat's last theorem and all that.
Right, sir.
He worked on modular arithmetic. And then 100 years later, Euler worked on the same thing with adding something more. And then another 100 years later, there came this young fellow, Galois, who died at the age of 19 or 20.
20. Right, sir.
Yeah, you are being an algebraist, you're familiar with Galois fields and
Gal.
all that.
Yes, sir.
Yeah, and of course, Galois was working with quintic, fifth degree equation.
Insolvability of quintic.
Fifth
Right, sir.
degree equation that has evolved to be a great branch of algebra field theory. And he
Yes.
probably didn't know this part of what we now call Galois fields and
Gal.
so on. But the essentials of all this were there in his overnight work or some few days work with Galois. So all these kind of mathematics evolved. And of course, Euler was a versatile mathematician. He not only thought of algebra or numbers, he thought of mechanics and all sorts of things. And I don't have to tell the modern students about Euler's name and his notations and that he comes into picture in number theory, in analysis, and in calculus of variations, and so on and so forth. So all this kind of algebra that has developed from Fermat to Galois are now used in our security systems, in our banking, giving our PIN codes or whatever. Now, all these are so they probably never thought. I mean, they were not intended. They didn't intend to do something which is going to be used
Applied
400 or
here.
500 years
Yes.
later in our present banking system or our security systems, military, and so on and so forth. So
Right, sir.
you can't separate pure from applied, so to say. If you like to call some areas as pure and some areas applied, it may be our own limitations. You see that natural limitations of time and space that we call ours, and also for matter of convenience, administrative convenience, these divisions are made. And there are many such instances. Like I can quote people, of course, I already mentioned of Fermat, Euler, and Galois, who lived several centuries ago. And then similarly, Newton lived a couple of centuries ago. And Newton invented calculus, if you may say so, to justify his mechanics.
True.
So what do you call him? Do you call him a pure mathematician or applied mathematician? That calculus that he developed has given rise to many branches nowadays, including the calculus of manifolds
Right, sir.
and and of course anything in the name of analysis owes its origin to Newton,
Calculus.
so to say.
Yes, sir.
And independent of Newton, I think it was Legendre or Leclerc.
Leibniz. Leibniz.
Leibniz, who developed calculus independently. He had nothing to do with mechanics. So
Right.
they think, evolve. The calculus of variations of Euler is now used in aerospace. Aerospace, in
Mm-hmm.
let alone, you can talk of satellites if you wish, satellite launching. So this sort of several centuries ago mathematics is now modern. You call it modern or applied or pure, you don't know. And then, so Newton was one. And then coming closer to our days, you can talk of Norbert Wiener and Raoul Bott. You algebra, algebraist, Raoul Bott, he was an analyst. And do you know Raoul Bott was an electrical engineer to begin with?
Mm-hmm.
And he was the first doctoral student of Archer Duffin, who was an electrical engineer, a physicist turned electrical engineer turned a powerful mathematician. And bought Duffin's first. I was one of the last students of Duffin.
Duffin.
Uh, he was the first student of Duffin, Raoul Bott. And if you go to his Robert Watt's biography, and he says, and his I had a chance to see his thesis at Carnegie Mellon, and his thesis was on algebra of networks. See, he takes up some network and finds an algebra in it, and he develops that algebra further.
Okay.
Right? That's what, and then of course, Watt's thesis also contains a paper, his joint work with R.J. Duffin. It's a beautiful application of one of the most difficult theorems, if you want to call, in pure mathematics. It is Cauchy's theorem. It's the hardest. If you do it properly, it's one of the difficult theorems to give a rigorous proof.
Okay.
Even though all shades of proofs are known, and engineering students, even an engineering student knows Cauchy's theorem now, its contents and how to apply it and so on. So it's needed very badly everywhere. And one of the first beautiful applications of Cauchy's theorem was done by Bott and Duffin as a part of Bott's thesis, and that is called a synthesis of, if I remember correctly, a synthesis of a network which contains only resistance, inductance, and mutual resistance and inductance and capacitance, no mutual inductance. That's called a transformerless synthesis. That's what we call. So
Okay.
in the design of filters, signal processing, for instance, you are mentioning electrical filters used in the synthesis. That's in the design problems. That's if you want to manufacture a filter for a certain purpose, you start with a function, a rational function of a complex variable, right? Which is called a positive real function. It has the property that its real part is positive. So that's the kind of the function associated with RLC network, as they say.
RLC.
That's typically a function that occurs in a design problem of in signal processing. Okay. People do not want mutual inductance because the mutual inductance or a transformer involves a lot of loss and design cost, so on and so forth. Okay. So till then, till Young Bott, and Duffin was slightly older by a few years, they appeared into picture. The companies, the electrical companies used to spend a lot of money in designing filters. Okay. And then because it involved a lot of cost. Now, by a simple application of Cauchy's theorem, they provided what is called a transformerless synthesis. So what do you call them? Engineers turned powerful mathematicians. And I know how powerful is Bott became as a mathematician, and many of Bott's students got Fields Medal. And somewhere he says that everything he did is a part of a whole. See, so whether he worked in network algebra or electrical networks, or with filters, or later on, what is it called? You know better. It is called symplectic. I don't know. Simplexes.
Symplectic geometry.
Yeah, he worked in and so on. So by many fields he worked, and so it's all a part of the whole. That's what he said somewhere in his one of his lectures. And Duffin, for instance, I already told you that he was a physicist to become an engineer to become, physicist to begin with, and then become an engineer and then a mathematician. And for instance, of course, he produced people like John Nash, who was a powerful mathematician, worked in cohomology and homology theory and whatnot, and he applied homology
Economics.
theory in economics problems and
Economics.
got a Nobel Prize in
Nobel Prize in
economics.
economics.
That
Right.
was an undergraduate student of Roger Duffin, and Duffin had already seen a genius in an undergraduate student, and he gives
Right.
a one-line letter.
Yes, sir. I had seen that.
Yeah, you have seen that. Yes.
Yeah, I've seen that letter.
But Nash is a genius. So that's the
Genius.
kind of that's
That's
the
the
kind of
letter.
that's the kind of work done by some people who do not distinguish things, or they drift, or they diversify, and then when they diversify, they unify. So, so this
Right.
sort of it's a continuous process. And Norbert Wiener, he to begin with, he was a student of life sciences, zoology and botany and so on and so forth. And then at a young age, he got a PhD in mathematics, in in the fundamentals of mathematics, like logics and so on and so
Logics.
forth.
Hmm.
And then he worked with engineers as his colleagues, and then he took up their problems, and then he could unify a lot of the other things, many body problems, problems in potential theory, and stochastic processes. He could unify all of them. And one of the most important things he did was with a surgeon, Norbert Wiener, if I remember correctly, a South American surgeon, and he thought of this negative feedback, which we all of us experience. The moment we put our foot on a thorn or something,
Hmm.
our reaction is a negative feedback phenomenon. So
Right.
Norbert Wiener used that to, just to formalize this phenomenon, biological phenomenon, whatever called phenomenon,
Reflex.
into mathematics, what you call negative feedback. And he applied it to all electrical gadgets. Any electrical gadget you think of in modern days, owes it to Norbert Wiener. There is a circuit called a negative feedback circuit.
Circuit.
And
Okay.
it was to a mathematician like Norbert Wiener, who was many-sided. You can't call him a pure mathematician or applied. Cybernetics. Cybernetics is full of analysis and also of algebra, depending upon what kind of problems you are dealing with. So, I think as I said before, the the more we expose ourselves, the lesser we are of either a pure mathematician or a
Or
applied or anything at all. See, when you read the
right.
biographies of these people, at least we have to read the biographies of some of these versatile people. Versatile.
Yes. Yes.
That,
I loved the analogy of floating canvas. Probably
uh,
that summarizes all that you were
correct.
explaining.
Maybe I gave a too long an answer. So
No,
that's the
sir.
situation.
That probably, as you said, that exposed us to something that we should wait and get exposed to.
Yeah,
Uh,
of course, we should not feel small. Everyone is not as great as. And of course, Ramanujan himself probably would have wondered that his mathematics was used by Baxter, uh, uh, Roger Baxter of Australia. No,
mhm.
uh, in his theoretical physics. See, you may be familiar with Roger's Ramanujan identities, a pair of
Yes, sir.
identities. Analysis people look at as a problem in analysis, or
Mhm.
identities in analysis. Number theorists will get number theory out of it, and there are algebraists who work on theta functions and elliptic functions to extract algebraic properties out of that, and so
Roger
on and so
Raman
forth.
identity.
And so
Yes,
on.
sir.
And probably Ramanujan, God knows how Ramanujan got hold of those identities, how he proved. And Rogers had independently done it. And Ramanujan came to know of it only when he got to Cambridge. And those two identities, which Ramanujan discovered in isolation, amidst all his problems due to poverty and being a college dropout, he discovered those two identities. Some 80 years after he had discovered, it so happened that Roger Baxter, I think that's his full name, of Australia, was struggling to find some analytic quantities or identities, gadgets to justify or unify or to sort of crystallize his work in theoretical physics. Some
Hmm.
uh, and Andrews was there. See, Andrews was there visiting, and he said, "Lo and behold, Ramanujan has already done what you want. So see, just try if these fit in." And
Okay.
then, much to the dismay of Baxter, said, "Well, these are precisely what I wanted." So some 80 years after Ramanujan, and Ramanujan will be turning in his grave. That
Hmm.
of course they fit into the area of theta functions and elliptic functions. That's a separate matter. But Ramanujan probably was not aware that 80 years after, Baxter would badly need those identities. There's another story. And also, what Ramanujan discovered in his deathbed,
Right.
Mach theta functions. And Mach theta functions, as you mentioned, are now applied in a few problems in
Cryptic,
physics.
cryptic problems.
Yes. Well, as I know, as I
Black hole
hear,
physics.
black body problem,
Black
black
hole
hole
physics.
problems, and
Yes,
so on
sir.
and so forth. And some of Ramanujan's trigonometric identities are used in signal processing nowadays, and so
Yes,
on
sir.
and so forth. So it's very hard in a long run. In a long run, it's very difficult to segregate. In fact, if you go through Wiener's works or Wiener's biography, Venus, it's hard to go through Venus' works. Uh, he sort of unified even humanities.
Hmm.
His his problems, his solutions of many body problems would also incorporate problems in economics, sociology. So he sort of unified, science and humanities and mathematics, different branches. Right? So so for people like Wiener wouldn't distinguish one branch of this knowledge with another branch of knowledge, or try to uh, name this as that pure or that as applicable or applied. These are only for the convenience of our administration, I think,
Right, sir.
part of compartmentalization. But also, it is necessary, of course, to some extent. But in the long run, probably when you go through all these historical developments, uh,
Hmm.
they're all one and the same,
Hmm.
a part of a whole, a
Right,
connected
sir.
whole, part of a connected whole. You can call it a manifold or something. A
Hmm.
manifold has a different structure, but it can have different structure in each neighborhood.
Yes, sir. Locally. Uh,
Yeah, locally they may be different, but globally it's
right.
a manifold. It's this part of
Right.
whole. It's all the one whole.
Right, sir. Right, sir.
That's
So, sir, one last question from point of view of a non-mathematician or somebody who is in pursuit of knowledge outside of mathematics. As
yeah,
you already spoke about a lot of mathematicians who were inspired by works of Ramanujan, and even
yeah.
today we know there are students who are working in Ramanujan's mathematics for obtaining their PhDs, even after 100 years. For somebody who is in pursuit of knowledge outside of mathematics, what are the takeaways from life of Ramanujan?
Well, so I think it can be simply put as a devotion to his or her field or fields of interest and choice, in spite of all odds, if any. It depends on the individual. All
Yes.
odds in life. Ramanujan's was, of course, an extreme case. He worked all the time, in spite of all kinds of odds he had to face, and even in sick bed for long years in England, for at least 2 years, if I'm correct, and 1 year of
Yes.
deathbed back in. He kept on working because I mean, even though he was a human being, I think he was an extreme case of a human being,
Hmm.
or a learner, or a worker, or a researcher, or a mathematician, or anything. So that kind of devotion and hard work is a common factor to all. Yes.
Right.
And of course, detailed history, the life of Ramanujan anyway. So,
Yes,
uh,
sir.
I
If I'm right, the mock theta function was discovered when he was on deathbed, isn't it, sir?
Yes, but I mean, certainly revealed it in his deathbed, Probably he's working for a long time, but
Okay.
his revelation was his last letter. It's also called last letter. A
Last
genius.
letter.
Ken Warner's called it last letter of a genius, something like
Mm,
that. And, so I
right.
think that's one devotion and hard work. They are one and the same. Uh, uh,
Uh,
that's probably one takeaway from Ramanujan's life.
okay. Okay, sir. And if you allow me, I would like to end this conversation with one hypothetical question.
Yeah, the answer would be
Uh,
hypothetical too.
the question is, had this genius Ramanujan lived for say a couple more decades,
Yeah.
what could have been the scenario? What do you see?
Yeah,
Today?
one obvious thing we can all think of was for the kind of human being he was and how devoted he was to his parents and the, the students who suffered from poverty because of his own experience. The first thing probably he would have written, he would have done on his return what to attend to his poor old parents, his wife, and to all poor students. He already had said that when he was told by Hardy that he was offered a position in return,
Mhm.
he told them, "Well, I'll accept that offer. When I accept that offer, I'll set aside a part of my earnings to so and so, so and so, so and so, my parents,
Mhm.
wife, and poor students, and I will also uh, dedicate some money to development of libraries." That he would have done, of course, and he would have done to the cause of mathematics, of course, and to the cause of mathematicians. Those are all obvious things we can think of. What he would have done right away after his return in a short period, but unfortunately, it didn't exist for a long time. And then
Yes.
academically speaking, see, you may have heard of the another genius, Paul Erdős, a Hungarian
Hungarian
mathematician,
mathematician. Yes,
who
sir.
lived up to ripe old age, unlike Ramanujan.
Yes.
And he was some 15 years younger to Ramanujan. And,
Mhm.
uh, and if Ramanujan, and probably, and Erdős was known as a traveling mathematician. He never accepted any post offered to him. He kept on traveling, and he was concerned with young people, especially young mathematicians. He would enter into their homes with a short notice or no notice, and then
Mhm.
engage himself with their mathematical problems or standing problems, collaborate, help, etc. etc. So he would do that all the time, and he would visit number of countries for that, all places. And he was fond of India also. He was
Right.
in Mysore, and
Oh, I didn't know that, sir.
he was in he was in Uttarakhand. He was in Madras. He was fond of Alladis, I would
Allad
say.
Alladi
Yeah,
Ramaswamy. Yeah.
Ramakrishna and his father. He
Mhm.
was he was fond of visiting Mysore. I'm certain that either Ramanujan would have visited him or Erdős. More likely, Erdős would have visited
Is that?
Ramanujan, and
Mhm.
and the two would have collaborated
Collaborate.
because Erdős tells. Now, Erdős gave a lecture in Madras. Ramanujan died during his birth centenary, Ramanujan's birth centenary conference held at Madras. And there
Mhm.
he says a few things. Oh, so, Herodotus as a boy of 17, because he was already a wonder kid, as you said,
Yes.
by that age, he was fascinated by Ramanujan's work on prime and composite numbers. Ramanujan obtained his first degree at Cambridge because of the thesis he wrote. Hardy exempted, saw that he got an exemption from coursework because Hardy was
Mhm.
afraid that he would never get a degree, as it happened in. Yeah.
Uh,
So he was afraid of that. So he put him through a research work, so to say. And Ramanujan got his degree because of the work in composite and prime numbers, composite numbers especially.
Highly
And
composite numbers.
Erdos happened, yeah, pardon, and Erdos had a chance to see that as a boy of 18, 17, especially
Mhm.
on prime numbers. Ramanujan's methods on and solving age-old problems, some of the like Bernoulli's and so on, with his own elementary and nice methods. So, and he was already influenced by Ramanujan's works at the age of 17, Haridas. And in the paper, Ramanujan and I written for the proceedings of the Ramanujan's birth centenary conference held in Madras. Haridas tells us about the influence of Ramanujan on his works, such as probabilistic number theory. And Ramanujan, along with Hardy, is supposed to be one of the founders of probabilistic number theory. Not pure number theory, it's probabilistic number theory.
Probabilistic number.
And yeah, and uh, and and uh, and an elementary proof of prime number theorem. See, so I'm sure that the two would have collaborated on what Haridas did on prime numbers later on. So that's that would have been a great collaborative work in their association. So probably that would have happened if Ramanujan was alive. And Ramanujan would have, in all likelihood, published proofs of at least some of his important theorems in classical as well as his own alternative theories of theta and elliptic functions. As I told, that he had his own way of, he had his own notations, he had his own definitions of what Jacobi and Weierstrass and Abel had in theta functions and elliptic functions. And they were very algebraic, actually. So algebraic and this kind of Ramanujan's definitions, help you to discover more and more, or redo more and more, which already existed in a more elegant way, so to say, of which Ramanujan was. That's one of the instances which brings out Ramanujan's elegance and formula beauty of his formulas and so on, compared to the Jacobi's, and in my personal opinion, and I published this too because nobody has objected to that. And so it's in contrast to the fund of formulas, rich fund of formulas you find in Jacobi's and Weierstrass works, Ramanujan's equivalents and more are elegant, are beautiful. So that's what Hardy said about, not particularly this of all. This is one of the examples. So probably you would have done some work, published some of his proofs, elementary proofs, if Ramanujan was, or some of his difficult theorems, difficult in the sense that the mathematicians who worked all along over decades have provided difficult proofs, using like modular function theory, which is a marriage between field theory and complex analysis. So that's kind of more difficult than elementary proofs that Ramanujan perhaps would have given. And Venkatachalangar, and in some cases me too, and some of my students, has tried to look at what possibly could have been Ramanujan's methods. Succeeded to some extent, elementary proofs.
Right.
That a high school student would understand. So probably Ramanujan published some very valuable proofs of that, and also probably this, the last letter that he wrote in his deathbed to his mentor Hardy was about a few definitions and few properties of what he called Mach theta functions. Ramanujan hardly gives any name to anything he writes in his large treasury of his discoveries. He doesn't give a name except here. Except in his last letter, he gives a name to his findings, false theta functions, Mach theta functions especially. And he does give a name to his functions, and he does give a few properties of his functions, but he doesn't give a definition of his functions. So what are Mach theta functions?
Okay.
And it took dozens of famous mathematicians to try and figure out what could be Ramanujan's definition of Mach theta function, and what more properties they can have about that. And a rich literature happened, and a number of famous mathematicians worked, and a number of famous other youngsters were produced. so on and so forth. But until about 80 years after that last letter was written, until that a young Dutch mathematician by name Zwegers came into picture, a definition of Mach theta function was not given. So he sort of settled the matter in a way, perhaps not the Ramanujan way, probably, but he did give. So it took 80 years to figure out what was in Ramanujan's last letter. And Ken Ono has written a nice article. You may have read it. It is published in American Mathematical Monthly or somewhere. I forget.
Okay.
And it's called The Last Letter of a Genius or
Genius.
something like that. Genius, and it's available on the internet or something. Then he gives, this was in 2002, that Zwegers settled the matter about Mach theta function. Probably Ramanujan would have done it himself if he were alive. So he would have shrunk these 8 years to a few months, perhaps.
Right.
And maybe hundreds of mathematicians that happened later on would have been out of business or would have not have produced. So there could have been another tragedy comedy among mathematicians as a whole if Ramanujan were alive. The comedy on one part, because Ramanujan would have given all his proofs.
Right.
Tragedy, many mathematicians would not have existed or would have run out of business, as you would put Americans would say. So that would have Ken Ono's paper. I think it came about 6 or 8 years ago. That short paper. It's a poetic paper. I would say it's almost poetic. And
Okay.
he does give few things beyond 2012 of what more was done on Mach theta functions beyond Zwegers and also what physicists have worked on out of Mach theta functions and what more is possible. So that Ken Ono's paper, it is readable. There are no you may find some formulas but no proofs. It's all poetic. It's very inspiring for youngsters to read.
Sure, sir.
So I think that would have happened if at least that much would have happened if we were alive for a few more years.
Right,
I don't know if I've thrown any light on your question.
Yes, sir, definitely.
I would definitely recommend all to dig out Ken Ono's paper.
Sure, sir. I personally would do that, and I'm sure those who are watching this will
It's
also
very
dig that up.
interestingly written. I mean, it's my phrase, poetic. It's really poetic. For instance, he compares the adventures of all the dozens of great mathematicians and their students and so on and so forth in trying to figure out the contents of the meaning of Ramanujan's cryptic letter, lost letter of the genius. He compares all their adventures to one of the adventure. What is it? Jones, Indiana Jones movies. You have seen some of Indiana Jones movies. They're all adventure movies. Like in Telugu, as a child, we used to go to Telugu movies, called Balanagamma, or where the hero has to kill a villain, and to kill a villain he has to pass 7 seas, 7 mountains, and huge jungles, and face a lot of wild animals. Ultimately, he will get into a cave where he has to find a little parrot and kill that parrot. If the parrot is killed, the villain is killed. This sort of adventure. The Indiana Jones movies is about the knights, the kings, knights. A king would ask a bunch of his knights, led by a soldier, a very efficient soldier, to pass through all the deserts and so on, forests and so on and so forth, and try to find what you call the the dish used by Jesus Christ, the Last Supper, see, and that is hidden somewhere. So that's a treasure or something similar. See, so that's Indiana Jones or some other treasure. There are a number of Indiana Jones movies. See, each one is of that kind, or some treasure finding. So he compares Ramanujan's Mark Theta function letter, last letter of the genius, cryptic last letter of the genius, to some such treasure, or it may be Egyptian rulers, uh, plagues, with written in a hidden language. Now, our shasanas like things,
Yes,
it may be very valuable. Which, if one can read that, so the whole lot of knights and other efficient soldiers would use all their might and strength to pass through all hurdles for hundreds of miles and finally get hold of that treasure. And only one will return. Hundreds of knights will go. So that sort of, he compares that sort of, it's very interesting to read.
sure, sure,
And
sir.
also, he gives mathematics and physics in it, apart from this sort of story.
Yes, sir. Thank you, sir. Thank you for recommending that. I will definitely go dig that out and I will read that.
Ken Vana was also in Mysore in 2012. He had come for, we had a meeting here, 2000 International, to commemorate Raman's 125th year of birth.
25th. Mm-hmm.
Ken Vana was there. Richard Askey was there. Unfortunately, he's no more. Richard Askey is one rare Americans or rare mathematicians who had everything in his fingertips.
Mm-hmm.
And he was expert in all of Ramanujan's works and everything. Unfortunately, he didn't publish much. So he was here, and he passed away recently, and his wife also, of Wisconsin. And incidentally, the ASCII's student, Cooper, Sean Cooper.
Sean Cooper. Yes.
I heard of him. I don't know whether you met him too. He was also in Mysore. He has come to Mysore a number of times. And Sean Cooper rewrote Venkatachalanga's. I mentioned Venkatachalanga's. Venkatachalanga's work on Ramanujan's last notebook. And Venkatachalanga's book, Development of Elliptic Functions According to Ramanujan. That's the title of his monograph. In fact, the monograph was published after Venkatachalanga's retirement when he was in Madurai as a UGC retired fellow or something like that. And unfortunately, it contained a lot of course, Venkatachalanga was my teacher also in Bangalore Central College. Later on, I became a younger colleague of his here. And his teaching was very unique. He expected his students to do a lot out of his classroom teaching. So he left a lot of gaps for students, to say the least. He was an exceptional teacher that way, so that many of his serious students would already become researchers in his class, honors classes, perhaps, probably, for instance. And so his writing were sloppy, I would say, and that monograph was full of printing errors.
Okay.
And Sean Cooper, I think it was a part of his thesis in Wisconsin as a student of ASCII to develop further or to put all the things in the right perspective of what Venkatachalanga had left. So anyway, he did write, he has written a book, Development of Elliptic Functions due to Ramanujan and Venkatachalanga. So he has rewritten and added more, and he has cleaned up all the mistakes and shortcomings in the Venkatachalanga's book. So Cooper is another person who he maybe he's in his late 40s. I'm not sure, or some mid 40s, and so I don't know why I brought these names in. So
you're talking about these people have visited Mysore, Ken Mono, and
I was Starting of ASCII and these people, Ken Ono. I started with Ken
Ken
Ono,
no no yes.
and then I added these names.
Right.
They have done wonderful work. They you can probably it's in your library you can get that Cooper's book on development of elliptic functions due to Venkatacharanga
Yes.
and Ramanujan.
Ramanujan and
Venkatacharanga's
Venkatacharanga.
Venkatacharanga's book was on Ramanujan's,
Yes.
and Cooper's work was on Venkatacharanga's book on Ramanujan.
Ramanujan. Right.
Last notebook. See, they and it's very readable. Cooper's book, and he has done a lot more. Of course, this is one, and it's very readable and it's elementary in the spirit of Ramanujan. See. And there is
Oh,
another book by Burnt. Uh, you know, in the spirit of Ramanujan, Ramanujan's elementary something in the spirit of Ramanujan. That's one of the clauses. It's a
okay.
Burnt's book. So that's if you want to know the elementary ways which Ramanujan thought, there are some available
Oh,
apart from some papers.
okay, sir.
I mean, this what probably Ramanujan would have done all this himself and published if he were alive. And as I said, that some of us would have been out of business, would have not existed. Okay,
Mhm. Right, sir. Uh,
these are only a few of the things.
okay. Okay, Professor. So I thank you very much once again on behalf of Chennai Vishwavidyapith. I wholeheartedly thank you for accepting our invitation and joining this conversation. I'm sure this inspiring conversation will interest our viewers to take up mathematics and become mathematicians or make a career in mathematics, I'm sure. And also, this has thrown light on the legacy of Srinivasa Ramanujan and seeing him's life and works through your lens. It was a great experience. It was my privilege to have you on this conversation, Professor. Thank you very much.
Thank you very much. Thank you.